So let's look at some memory, big data and SIEM as part of this presentation. Okay, so initially we'll look at Security, Information and Event Management, or SIEM. Later on in the presentations we'll have a look at Splunk and how it uses security information and event management to be able to analyze and link data. Then we'll have a little look at machines and data, and then on to directed graphs. Look again at the V's of big data and the most significant ones, and then on to data gathering and building a timeline. Okay, so this is what modern day data infrastructure could look like. So what we have is typically semi-structured data, so that might be gathered from logs across the network. We then have some form of aggregation that will bring all those logs together. This might be in terms of a syslog server where we can forward our logs to the syslog server and pick them up from there. Or we might have agents around, software agents around the network, gathering the logs and then pushing them into our data infrastructure. After that, we will parse and normalize our data, really getting rid of the data that we don't actually need, or perhaps cleaning it up in some way. From there, we might be storing our short-term data somewhere. Perhaps 2 gigabytes of data per day is gathered from our infrastructure. Obviously, it depends on the size of the network that we have and the amount of services that we have running, but we might be gathering more than 10 million events from our networks. Good logins, bad logins, and lots of different events gathered. Then we process these, put some context into the logs that we see, and then we might reduce down into tens of thousands of alerts that need to be processed, typically by human operators, and we might then find, say, one incident in those thousands of alerts. As part of the processing, we can use role-based correlation, statistical correlation, or event prioritization. So we might find that a bad login on a critical server might have prioritization over, say, an alert where someone is pinging a computer on the network. And this all really goes into our SIEM infrastructure. Okay, so let's look at machines and data. So overall, within our data infrastructure, we want it to be adaptable. And to be adaptable, we need to make sure that we have certain rules that we will run on the data, but over time these rules need to change depending on new attacks and so on. So often what we might have is fixed high-level rules that need to run, and then we will use machine learning to be able to adapt our rules to optimize them and to be able to learn new attacks. We also want it to be interactive, and as part of that, we need to make sure that we're taking data from the logs and from the sensors within our cyber network, and then we need to be able to process that in the way that our brain does as a cognitive ability, and then to be able to have some form of output onto the infrastructure. Then we want it to be iterative and stateful. So being stateful, then the SIEM infrastructure will understand the state that something is in and then move into another state. So it might differentiate a user who is logged in, who now goes and consumes a service and then logs out. We would assume that is a stateful system, and it's also iterative. Sometimes we need to know when something goes from one state to another, but then into an unlikely state. That's what's called an anomaly, and we want to be able to understand how probable it is for someone to move from one state or something to move from one state to another. And we also want it to be contextual, and that is adding things like locations, names, IP addresses, usernames, MAC addresses, and so on onto our data. So our data itself might be unstructured or semi-structured or even structured, but we want to add on other elements onto the data that we have to give it context. And one way that we do this is with what's called directed graphs and mapping cyber threats. So the directed graph might look something like this. So we might have an IP address, and that belongs to an organization, and we might have an FTP service is hosted on a second level domain in this case. So in this case, we can actually start to link together entities that are associated with each other. So here we have a person may be associated with an IP address, and they may be associated with a certain organization. In this way, we can build fairly complex graphs based on the data that we have, and then try to create the linkages. Obviously, if we get the linkages wrong, then we could cause a whole lot of problems. Okay, so this is an example here of a directed graph where we're mapping users to organizations and then onto IDs and so on. And Splunk does this in terms of taking a semi-structured log and then finding linkages inside it to the fields that it has. And later on, we'll be looking at how Splunk can actually be used to be able to search through the directed graph. So what are the V's of big data? Well, the four of the important V's are these. The veracity of the data is extremely important, and we need to understand how trustworthy is the data that we're receiving. Because if we get bad data in, it could corrupt our data infrastructure. So it's important that we understand how trustworthy the data is that we're receiving, and hopefully mark it in some way for that veracity. An important element is velocity, and the problem with velocity is that if we're sitting in a core network switch, the velocity of the data, the speed of the data may be too fast that we can't actually cope with that speed. So we need to make sure that we distribute our data gathering, we aggregate, we bring data together, and we maybe try to compress it down or to slow it down. So we might be having buffers or caches, or we may be storing memory locally for a while before we will then process it and take the data out. And then there is the variety, and there's many different sources of data, including text, ASCII, images, audio, video, and so on. So we need to understand all the different data types that we have, and to make sure that we can still process them and understand the formats and get the data back. And then, of course, there's the volume. Our license for our SIEM infrastructure might relate to the volume of data that we store or that we analyze. So the volume of data is very important. Along with this, we don't want to swamp our infrastructure having too much data. It might affect our production and environment. But the great thing is that from our SIEM data, we can produce management reports, sales analysis, targeted marketing, trends, correlations, and use it for instant response too. So if we can get this to work and we can gather data from all the different elements of the network infrastructure, we could use it to really understand the whole analytics of our company. Okay, so let's have a look at what the data gathering looks like. So within our security operations center, we might be gathering information around users, network devices, and so on. These logs and alerts will then be integrated into our SIEM package, such as Splunk. And then an analyst can actually analyze events as they come in and try to correlate them to other events. But along with this, an analyst may be looking at the news feeds to see if there's the latest ransomware or a latest hack that's happening in a region of the world. And then they might also be looking at the latest security alerts and the new 0 days and so on, and prototyping them to understand how they actually work, so that when they see the signs of these attacks, they will understand them because they have analyzed them. So for an analyst, it's a long task of continually learning, continually analyzing alerts, and to look ahead. Increasingly, we might even be using threat hunting to be able to see what threats are on the landscape and try and learn them before they're actually seen in the wild. So what we often define is before an incident, during an incident, and then after the incident. Before the incident, we want to make sure that we set up our timelines of data, our data analysis, to make sure that when an incident happens, we can go back and actually trace back through time and link elements. So this might involve looking at data at rest. So that's typically a CRUD, create, read, update, delete analysis on files. And we will look at when files change, when file rights have changed, domain rights, and so on. Then we might look at data in motion, looking at network scanners, IDS systems, firewall logs, and so on. In terms of this, we might look at packet logs, web logs, and security logs to look at the network traffic as it was in motion and captured it. And then we might look at data in process, and that's the processes, the executables, and the running memory, the exceptions, and so on. As part of that, we might look with inside security logs, application logs, registries, and domain rights, and so on. Within an incident, we then have to pick off what's happened and try to quickly understand the scope of the threat and how it could be mitigated against. And then after the incident, we might be looking at some forensics analysis and trying to understand what happened. Then we obviously want to make sure that we rebuild for the future and make sure that we stop incidents from happening in the first place. So we're feeding back to make sure that the incident is stopped or the data is gathered that we need to be able to detect the threat at an early stage. So some of the logs that we pick up from the network, TCP logs, we might even be looking at environmental data for our security operations center, for data center. Active Directory gives us a whole lot of logs on user changes, hosts, when people log in and so on. IDS system, email, print monitoring even, remote access, VPNs and so on, database accesses, performance on hosts, file systems, and host logs for application security and system. A massive amount of data can actually be gathered and you can never quite know what sort of information that you're going to require to build up a timeline of an intrusion. And the big problem is that most networks have some horizontal and vertical stack. So we might see Apache or IIS for web services, for IT ops. We might have NetApp for network security. We might be using Syslog or Cisco NetFlow and Snort. And we have different databases, different data structures. A Microsoft infrastructure, typically Active Directory, Exchange and SharePoint, and we might be also integrating in with our cloud into AWS or S3 or Azure, and then we have our application server infrastructure. Along with this, we've got lots of logs and lots of devices and users and so on. So it's pretty much a patchwork of trying to understand how all this fits together and how we can then use that to be able to analyze our events. So we have data in transit, so we might have devices which are picking up network traffic as it goes. We have data in use, and that's inside the memory and the processor, and also data at rest, and that's files that are stored on our disks. An important element is then to build up a timeline of an incident. So the timeline might be coming in from our internal systems. We might be gathering data from trusted partners. We might also be looking at open source intelligence, but then getting information too from our internet service providers and communication providers. So this can be a patchwork of trying to understand how we use the data from each of the elements. So we might see something starting off on Facebook, and then a trusted partner sees something, and then we see something else, and then there's an event inside our communication service provider. Okay, so here's an incident. We go through various steps, and each part here, Eve is probably leaving behind a trail of evidence. So we might see a cell record for her call, location is mapped here, she tweets, there's a log there, she does something on Facebook, system log when she logs into her system, there's an internet cache, web logs, and so on. So along the way, there's a whole lot of evidence that's built up inside the logs that are held on different devices and within different domains. Okay, so that's been a basic introduction to memory, big data, and SIEM. Sorry about that, Joe. Hopefully that's recorded.